So I'm Kyle Seferati, and I'm doing a review and application of the paper titled An Application of Analytic Hierarchy Process in Real-World Problem of Store Location Selection. Problem description. Location selection problem involves a lot of different things such as profitability, cost-cutting, boosting, durability, and efficiency. You have to look at considerations such as land and number of people when determining this is a company. In order to reach their goals regarding above, companies have to select their locations by considering all of these different criteria and using convenient methods. For this specific option, AHP proves to be one of the best methods to compare all of these options. So in this study specifically, a store location selection problem for Carglass Turkey is handled. Carglass is a company in Turkey, and currently only in Turkey, that will repair cars and maintains cars. So they're looking for a new location for their business. The reason that I wanted to do this problem was a supply chain manager actually came to the authors of this paper and asked them to help him with it. So I think it would be neat to have this knowledge as a supply chain manager, because that's a direction that I'm looking to go into. So AHP, the way they used AHP in this journal paper was first they identified the alternatives, main and sub-criteria. Then they organized these alternatives into a hierarchy, and they modeled it out considering what was more important than the next. These were all unanimously determined and selected upon by the whole team. Then all these decision makers were the team's judgments were collected through pairwise comparisons. They labeled 1 through 9 as more important, barely more important, and very more important, extremely more important. And they asked all of the decision makers. Then they went back, they found the average, and they went back to the decision makers. They said, this was the average of pairwise comparisons. Do you guys concur? And then after concur from the decision makers, the authors continued in the process of AHP. The final step was to determine the relative importance levels in accordance with the judgments. And this involves looking at the importance level of each location with respect to the criteria and sub-criteria. So this is how they laid out the hierarchical model. And these were the initial factors given by the journal. Note, there will be some errors. For instance, one of my critiques of this paper is these numbers do not add to 1. The first number represents the overall weight of each big criteria category, and the rest of the numbers are just the sub-criteria's weight, so the rest of the numbers should add up to 1, and in this category alone they do not. So that is a critique. And also these, as I will display, these sectoral factors, environmental factors, these weights were not correctly calculated from a AHP method, because they actually list the table of pairwise comparisons for the overall criteria, and that's the only pairwise comparison table they list. And after doing the comparisons on that, you get different weights. So we're going to go over to Excel. All the data is currently in Access, so we're going to get the data from Access. Now we're going to calculate the weights. Then we're going to view our options. And then we would like to go up here, make sure everything is labeled. And so we'll notice a small error. We're going to move that there, the labor potential. And you can see all the relative weights. Right here we have a 0.88. This is from this chart that they give us as well in the paper. And you get these weights. And when you go down here, you have once again your same 0.88, and as I showed in the PowerPoint, they have 0.78. All of these main numbers are slightly off also. You can see only in the sectoral factors category the numbers are off. Nearness to market they have as 0.208, and nearness to market when actually calculated was 0.175. So their method of calculation differs from the normal method, which is a critique of mine. Now, they also, for the final step of the AHP method, it was to assign relative just values for each of the different location options. So this is all theoretical information that I inserted in order to get to simulate the kind of results they got. They have 61%, about 61%, just under 30%, and about 10% for their options respectively. So I put in values so you can visually see how these different layouts could have compared, most likely looked. Whereas certain ones have 10s in different places, but when you put it through this whole model, you can actually see that some stand out much more than the other. So we'll jump over to the paper. Paper, you see all the weights. This is the chart that was used to initially notice that the calculations were off, and these do not add up to 1, so that's why we had to redefine all of those numbers as well. And these were the three values that they gave us: 61%, 29%, and 9%, but they didn't give any information on the alternatives, and this was the last step of AHP. So as a critique, I wish they would have given us this information, because that is still a big part of the AHP model. But so these numbers closely represent what it could have been. And over here we have our overall category weights. Unless for these there's no sum criteria, so the overall category weight is right there. And if we select our best option, we have a 61%, so option L1 was selected right there. And these all have macros assigned to them, so if we go to assign macro, you can see this has the Carglass tables macro assigned to it, and so forth. So that's how all of that worked. Now if we bring it over to C#, just for a brief C# implementation, we can run this. This shows us all the tables. We can look at all these. Look at all the data that was given. For instance, this, we go right here, this 1.18 on category 2 means the nearness to market is 1.18 times more important than the nearness to the warehouse. So that's how the normal AHP works. And now this was done manually. I entered the answer. So inside of AHP, it tells us to choose option L1. The calculations were not done for C# through that. We just have the tables in C#, and they display here. And that comes directly from the Access database as well. You can see that with this code, bringing it all in. So back to the PowerPoint. We've discussed the hierarchical model, the relative weights. So some of the results: the journal versus reproduction. Since the location values were not explicitly given, there's only a way to theoretically compare, as I showed with the values assigned for each location. And they do happen to be fairly accurate after a little bit of manipulation. So we can conclude that our descriptions of the locations were fairly accurate. So we were able to end with similar results. Some critique: there were only 3 locations, and these locations were not given to us. It would have been nice to have a few more, or maybe some more competitive locations. The weights were not consistent and did not add up to 1. Values were not given for the last step, and the regional potential had by far the greatest influence. It was right at about 56% influence we calculated, but it was defined by only 2 sub-criteria. So this is okay, but it would have been nice to see it defined by more sub-criteria. So there would have been more options for the best situation. Some future research: location selection does depend on a lot of factors. So there's a lot of other ways to implement this, and maybe we would look at multiple locations. Should we put multiple locations? How would we determine that? And also, I think it would be very interesting to look at cross-continental factors. This was just done in Turkey, so they didn't take into consideration an individual's likelihood to go to a Turkey-based company if they did it in Japan, or rather if they would want to start in China. So how would you can add in to the AHP model cultural subjectivities and stereotypes in which location is best to select? And so this is just the conclusion. This is the reference. This is the paper that was cited. And that is everything. Thank you very much.